we carve up OSPF into multiple areas to enhance the scalability of this. Hierarchical means a structure, a tiered structure. IP addresses are hierarchical because we have a network portion and a host portion. An OSPF autonomous system is hierarchical because we carve it up into multiple areas. Now, there is a very essential area, numerically and operationally. We call it the backbone area, and it must be Area 0. Area 0 forms the hub of the hub and spoke topology of OSPF. Now, when you think of hub and spoke, you think typically about maybe a switched environment or a WAN connection, where we talk about that as being hub and spoke. The element that is hub and spoke in OSPF is, in fact, OSPF areas. The Area 0 is the hub area, and the other areas, the non-zero areas, the non-backbone areas, those are spoke areas. And so what happens with this structure now, because we have taken our OSPF autonomous system and carved it up into multiple areas, we have simplified the topology from the perspective of Dijkstra's shortest path first algorithm. Dijkstra's shortest path first algorithm tells us how we get around our own areas. Now, Dijkstra's shortest path first algorithm wants to see about 50 routers in an area. If we have too many routers, we probably have too many networks and too complex a topology with too many options. So what we do is we simplify it for OSPF, and by simplifying it through area design, we make OSPF much more scalable. OSPF's hierarchical structure gives us a few different router types that we need to be mindful of. Let's look at them. The most basic router type of all in OSPF is an internal router. An internal router is one that has all of its interfaces in the same area. This means that it must not be an area border router. More on that later. But internal routers have all of their interfaces in the same area. So if we were to look at which are internal routers, I would want you to think, I've got my router 5 over there, router 1, and then router 6. Those are the internal routers of this topology. On internal routers, there's really not much going on that is special. We also know that there is a backbone area in OSPF, and any router that attaches to the backbone area is considered a backbone router. So we have 4 backbone routers in this topology, and I want you to recognize something right now. We have these 4 backbone routers, and we can see that we have roles that are not mutually exclusive. We have these router types where we might, in fact, be a backbone router and an internal router. R1 is such an example. Okay, so if you have any interface in the backbone area, then you are a backbone router. And remember, Area 0 is the backbone area. Then we have routers that sit on the fence between 2 different areas. One of them has to be the backbone router, or the backbone area. One of those interfaces must be connected to the backbone area on an area border router, because we have to recognize the significance of the backbone. Non-backbone areas need to connect directly to the backbone, and ABRs represent the glue for that. So the way that I want you to think of this is an ABR is sitting on the fence. On one side, the backbone area. On the other side, a non-backbone area. So area border router is the acronym here. And I don't want you to confuse that with the other acronym name OSPF router type, and that is an ASBR. That is an autonomous system boundary router. Now I want you to look at the name of this router type, autonomous system. An autonomous system is a routing domain, a collection of routers under a common administrative authority. And in this case, the authority is really OSPF. Although OSPF is not an authority, an autonomous system boundary router connects a collection of OSPF-speaking routers that are sharing information to some other routing domain. That could be an EIGRP routing domain, a Border Gateway Protocol autonomous system, RIP, ISIS. It could even be another OSPF autonomous system that is separated and not natively sharing routes between the two routing domains. And there is a technique that we use on all ASBRs, and it is called redistribution. I really want you to associate that and understand that ASBRs perform redistribution. And redistribution is a process by which we import information into the routing protocol, and that imported information then is injected to the OSPF autonomous system as external OSPF routes. So understand these four basic router types. That's quite significant to us.